Distance equals rate times time problems. These are problems where travelers are moving toward one another or away from one another. In this video, we're going to analyze some problems with known quantities and then use our analysis to set up equations for problems with unknown quantities. We'll solve the equations and we'll write the solutions in terms of the original problem.
These two trains begin at the same place and travel away from each other. The top train is traveling 60 miles an hour and the bottom train is traveling 10 miles an hour. How far apart will they be after 2 hours? Well, the distance traveled by the train going left is equal to the rate times the time. The rate is 60 miles an hour and the time is 2 hours, so that train has gone a total of 120 miles. The train traveling to the right has gone a distance equal to its rate times the time. Its rate is 10 miles an hour and the time is 2 hours, so it's gone a distance of 20 miles. Their distance apart is going to be the sum of the two individual distances they traveled from the starting point. So let's use this template. The first distance is the rate of the first train times the time of the first train, and the second distance is the rate of the second train times the time of the second train, and we add them together to get the total distance. Let's try this out on a word problem. Well, here's a traveling away word problem. Two trains left a station at the same time, one traveling east and the other traveling west. The eastbound train was traveling 20 miles an hour faster than the westbound train. After 3 hours, the trains were 156 miles apart. What was the speed of each train? Well, when we analyzed this problem before, we found that the total distance was equal to the distance traveled by one train plus the distance traveled by the other train. And we figured out each of those distances by multiplying a rate times a time. Let's let the westbound train be red and the eastbound train be blue. Then the first distance comes from the rate of the westbound train times the time. I don't know the rate. That's what I'm trying to find out. What was the speed of each train? But I do know the time. It was 3 hours. And that's the same time for both trains, so I'm just going to fill it in the T spot. Now the total distance I also know, it's 156 miles, so I'm going to fill that in for the total. And so now the question is, what should I do about the rates? Well, I have a sentence that explains their relationship. The eastbound train was traveling 20 miles per hour faster than the westbound train. Let's let W stand for the rate of the westbound train and E stand for the rate of the eastbound train. Our relationship sentence says that the eastbound train was traveling 20 miles an hour faster than the westbound train. So E, the eastbound train rate, is more than the westbound train rate. It's equal to the westbound train rate plus 20. For example, if the eastbound train is going 40 miles an hour, the westbound train must be going only 20 because 20 plus 20 makes 40. So I'm going to substitute W plus 20 for E so that I have only one variable in my equation. Now it's going to look like this. W times 3 plus W plus 20 times 3 equals the total distance, 156. We now have set up an equation with only one variable to represent the problem, so let's solve the equation. Here's the equation we found. Let's simplify it. W times 3 is written 3W. We distribute the 3 into the parentheses, so 3 times W plus 3 times 20 is 60. All those things are added together, and the total is 156. Gather the like terms, 3W and 3W. That gives us 6W plus 60 equals 156. Subtract that 60 from each side, and we get 6W equals 96. Divide by 6, and W equals 16. Well, what did W stand for again? The speed of the westbound train. So W equals 16. That units are miles per hour. Our relationship that we had between the two rates was that the eastbound train is equal to the speed of the eastbound train is equal to the speed of the westbound train plus 20. So if I know that the westbound train was going 16 miles an hour and I add 20 to that, I get 36, which gives me that the eastbound train was traveling 36 miles per hour. Since the question asked us what was the speed of each train, we found the answer. A traveling toward problem begins with travelers a fixed distance apart, and the question is usually about where they meet. Well, let's watch these trains chug towards each other on the number line. The train on the left will have gone 30 miles after 1 hour, and the train on the right will have gone 10 miles. After the next hour, the train on the left will have gone 30 more miles, and the train on the right will have gone 10 more. After 3 hours, we see that the trains are in the same spot, although hopefully not on the same track. Well, so what happened here? We have the distance traveled by the first train, which was the rate times the time, and the distance traveled by the other train, again, its rate times its time, and together those two add up to the total distance between where they started. In fact, a traveling toward problem sets up in the exact same way as a traveling away problem. The first distance comes from the rate times the time of the first train, and the second distance comes from the rate times the time of the second train. Those are added together to get the total distance. Well, let's use that analysis to solve a word problem. Two train stations are 120 miles apart. A train departed each station at the same time, traveling toward the opposite station. One train was traveling 22 miles an hour, and the other was traveling 38 miles an hour. At what time will they pass one another? The distance traveled by the first train will be its rate times its time. We're going to add that to the distance traveled by the second train, which is equal to its rate times its time. And the sum of those two is going to make the total distance. Fill in the numbers we know. We know the total distance, d, 120, and we know the rate of each train. 22 is the rate of the first train, and 38 is the rate of the second train. Now what about the times? Well, They started at the same time and we're recording the time until they pass each other. So they've each traveled the same amount of time, and we can call that value t. Each one has traveled for t hours. Well, let's simplify that equation. 22t plus 38t equals 120. 22t and 38t are like terms, and 22 plus 38 is 60, so 60t equals 120. Divide by 60, t equals 2. T is a time in hours, so t is 2 hours, and after 2 hours, the trains will have passed one another. We solved it. So if you're setting up a word problem where travelers are moving either toward or away, we're going to use the same format. The first distance, which is the rate times the time, plus the second distance, again a rate times the time, will equal the total distance.